So I'm starting new room, volatility, learn how to perform memory forensics with volatility. Volatility Sandbox version 3.8. Introduction. Volatility is free memory forensic tool developed, maintained by Volatility Foundation, commonly used by malware or SOC analysis within a black team or as a part of the detection and monitoring solution. Volatility is written in Python and is made up of Python plugins and modules designed as plug and play way of analyzing memory dumps. Volatility is available for Windows, Linux, macOS, and is written purely in Python. We already understood it. So we have here sample for Volatility Foundation. Before completing this room, we recommend completing core processes room. Okay. If you plan on using your own machine, okay, attached or run volatility, download the files attached to this task. Here are the files you can download if you want. I'm using the machine. Here it is. For the Volatility Foundation, volatility is the most widely used framework for extracting digital artifacts from volatility memory RAM samples. The extraction techniques are performed completely independent of the system being investigated, but offer visibility into runtime state of the system. The framework is intended to introduce people to the technique and complexities associated with extracting digital artifacts from volatility memory samples and provide platform for further work into the exciting area of research. Volatility is built of multiple plugins working together and obtaining information from memory dump. To begin analyzing a dump, you will first need to identify the image type. There are multiple ways to identify information that we will cover further in later tasks. Once you have your image type plugins sorted, you can then begin analyzing dump by using various volatility plugins against it, and we'll cover it in depth in later in this room. Since volatility is entirely independent of the system under investigation, this allows complete segmentation but full insight into the running system or state of the system. Basically the state of the system of the image. Edit our writing to main. So we have volatility that works with Python 2 and Python 3. Here we will be using volatility version 3. Okay. Then the get blog post. Okay, so I started the machine and we can start this room. Okay, infected. Not interested. Let's see. Extracted memory dump can perform numerous ways, various based requirements of your investigation. FTK imager, red line, dump it, WinDD, Win32DD, Win64DD, memorize, fast dump. When using an extraction tool on a bare metal host, you can usually take the considerable amount of time. Take this into consideration during your investigation if time is constrained. Most of the tools mentioned above for the memory extraction will output raw file with exception of readline that can use all agents and session structures. Let me real quick see what we need to have in this room. Yara, Capstone, Volatility 3. Okay. So for virtual machine gathering in a memory file can easily be done by collecting the virtual memory file from the host machine drive. This can be, so we can simply take VM mem, bin mem for parallels and save for the partition memory. Okay. So now this is covering Python 3 plugin structure of the volatility has changed quite drastically. In various volatility versions, you would need to identify a specific OS profile extract to operating system build version of the host, which could be hard to find or used with the plugin could provide false positives. Volatility 3 has been scrapped and volatility will automatically identify the host and build of the memory. Okay, so we have improvement on the volatility, if I understand the right. The naming structure of the plugin has also changed. In previous version of the volatility, name convention has been simply the name of the plugin, has universal for all operating system. In Volatility 3, you need to specify the operating system prior to specifying the plugin to be used. So it's improved in one areas, but it fucked up in some other areas. So this is because there are no longer profiles to distinguish between the various operating systems. For plugins and such, operating systems have drastically different memory. So we have Windows, Linux, and Mac. There are several plugins in Volatility S3 plugin. Read above. Okay. Menu. Plugins. So hint H. Okay. Let's see. Python 3. Vol. Locate. Vol. Okay. py. Just started. Wait a second. I don't supposed to. Cannot be opened temporarily. Whoa. Why did you infected? Infected. Am I? I am. Admin on the box. Okay. Okay. So we don't have to. H. Okay. So we have familiarized ourselves with extend Linux checks EFLs, p3, if config, mount, timer socket, DLL list. drivers dump files info. Okay. Let's say we just familiarized ourselves. By default, Volatility comes with existing Windows profiles from XP to 10. Images profiles can be hard to determine if you do not know exactly what version and building machine you extract a memory dump from was. In some cases, you may be given a memory file with no other context, and it is up to you to figure out where to go from there. In that case, Volatility has our backup back and comes with image info plugin. This plugin will take the provided memory dump and assign it to the list of best possible OS profiles. OS profiles have since been deprecated with Volatility 3, so we will only need to worry about identify the profile if using Volatility 2. This makes life much easier for analyzing memory dumps. Note, it's not always correct, can have various results depending on the provided dump. Use with caution and test multiple profiles from the provided list, though image info is not always good. If you are still looking to get information about what host is running from the memory dump, we can use every operating system info. So now file, read the above dump windows info. Okay. So the first task is scenario investigation. Okay, we have this one and this one. Wait a second. Volatility vol.py f file scenarios. Let's say 1 VM Windows info, image info, Windows Intel Pi, wait a second, image info, error in argument. So basically memory file layer through JSON file volatility JSON ZS symbols falls through. Okay, I've done everything that was assigned to 5 different plugins. Let's say we have autocomplete, windows.pslist. If I can type. Okay, every possible. So this plugin process list will get the list of the processes from the double linked list that keeps track of processes in memory equivalent to the process list in the task manager. The output from this plugin will include all current processes and terminated processes with the exit times. Okay, very helpful. So volatility, you can dump processes network, each with various techniques used. In this task, we will be discussing each of its. Okay, now some malware, typically rootkits, will, in an attempt to hide their process, unlink itself from the list. By linking themselves from the list, you will no longer see their process when using plist. To combat this evasion technique, we can use psscan. This technique of listing processes will locate processes by finding data structure that match process. While this technique can help with evasion countermeasure, it can also cause false positives. Okay. psscan. psscan. So psscan. Third process plugin, pstree, does not offer any other kind of special technique to help identify evasion like the last two plugins. However, this will list all processes based on their parent process ID. Using this method, as it can be useful for an analyst to get full story of the processes and what may have been occurring at the time of extraction. I can say that it can be very helpful. pstree sounds like good idea to see the parent processes. So, because we have the poster of sons that have processes and its parent processes that can be legitimate and those that are not legitimate, or you won't see them in the process list. Okay. Explorer, reader, SL, exe. I already see some eyebrow browsing file. SL reader. Maybe I'm wrong, but let's see. Windows. Next one is Windows netstat. Identify process can be also have a way to identify the network connection present at the time of extraction on the host machine. Netstat will attempt to identify all memory structure with the network connection. Wait, what? Netstat. What I'm doing wrong? Okay, Volatility 3 is showing us the error hell. Windows netstat. Okay, you don't want to show us. This command currently Volatility unstable, but declare around all the Windows builds. Okay, so with those instability of this command, to combat this, you can utilize other tools like bulk extractor to extract the pickup file from the memory file. In some cases, this is preferred machine network connection cannot identify volatility alone. Bulk extractor. Okay, DLL list. There is 3 L's. DLL list. Whoa, dude. Bunch of list. Bunch of DLLs. Okay, fine. So bulk extractor. Do we have bulk extractor in here? Bulk extractor. We do not have bulk extractor in this machine. Volatility offers a plethora of plugins that can be used to aid in your hunting and detection capabilities when hunting for malware or other anomalies with the system's memory. It is recommended that you have the basic understanding of how evasion techniques and various malware techniques are employed by adversaries, as well as how to handle and detect them before going through this section. The first plugin we will be talking about is one of the most useful when hunting for code injection is malfind. This plugin will attempt to identify the injected processes and their post ID along with the offset address and hex, ASCII and disassembly view of the infected area. The plugin works by scanning the heap and identifying processes that have the executable bit set RWE or RX and or no memory mapped file on a disk. Fileless malware based on the malfind on what malfind identified the injected area will change and MZ header is an authenticator of Windows executable file. The injected area could also be directed towards shellcode, which requires further analysis. So let's malfind on this one, and we see explore. Oh, here we go. This one. Okay. Volatility also offers the capability to compare the memory file against Yara rules. Yara Scan will search for strings, patterns, or compound rules against a rule set. You can either use Yara files as an argument or list rules with this command: Windows Yara Scan. Yara Scan. There are other plugins can be considered. Windows Yara Scan. Yara Scan, and Yara Scan is not working. At least for me. Yara Scan. Nope. Not working for me at all. Let me do something else. Opt vol h grep Yara Scan. We do have Yara Scan here. Plugins Yara Scan VAD Yara. VAD Yara. There are other plugins, however, we'll be covering them in the next task. Okay, Yara Scan is not working. For sure, for this file at least. Invalid choice, Yara Scan, choose before. It was malfind. Okay. Advanced memory forensic can be confusing when you begin talk about system objects and how malware interacts directly with the system, especially if you do not have prior experience hunting some of the techniques used, such as hooking and driver manipulation. When dealing with the advanced adversary, you may encounter malware, most of the time rootkits, that will employ very nasty invasion measures that will require you as an analyst to dive into the drivers, mutex, and hooked functions. A number of modules can help us in this journey further uncover malware hiding within memory. The first evasion technique we will be hunting is hooking. There are 5 methods of hooking employed by adversary outlined below: SSTD hooks, IRP hooks, IAT hooks, EAT hooks, inline hooks. We will only be focusing on SSDT hooking as one of the most common techniques when dealing with the malware evasion, and the easiest plugin to use with the base volatility plugins. The STD plugin will search for hooks and output its result. Hooking can be used by legitimate application, so it is up to you as an analyst to identify what is evil. As a brief overview of what SSDT hooking is, stands for System Service Descriptor Table. Okay, the Windows kernel uses this table to look up system functions. An adversary can hook into this table and modify pointers to point to a location the rootkit controls. There can be hundreds of table entries. SSDT will dump. You will then have to analyze the output further or compare against the baseline. Another suggestion is to use this plugin after investigating the initial compromise and working off it as part of the lead investigation. SSDT. Okay. Okay, we can see the hooks. For now, it's not that helping, but we have the address of every hook. The same we will see in here with a map, Windows SSDT, hooks. Okay, adversary will also use malicious driver as a part of their evasion. Volatility offers 2 plugins to list drivers modules. Plugin will dump list of loaded kernel modules. This can be useful in identifying active malware. However, if a malicious file is idly waiting or hiding, this plugin may miss it. This plugin is best used once you have further investigated and found potential indicators to use as an input for search or filtering. Okay, let's see. Modules. Okay, what a mess. dump. Okay. Driver scan. Plugin will scan for drivers present on the system at the time of extraction. This plugin can help identify drivers files and can note that the modules plugin may have missed or were hidden. As with the last plugin, it is again recommended to have the prior investigation before moving on to this plugin. It is also recommended to look through the modules before driver scan. So driver scan. Okay. Nothing in here. In most cases, we can with no output. However, if you do not find anything with the module plugin, it can be useful to attempt using this plugin. Callbacks, IDD, API hooks, handles, callbacks. Okay. Mode scan. No, IDT. Okay. There are also plugins listed below can be helpful when attempting to hide the advanced malware in memory. API hooks. Okay. Mode dump. Handles. Whoa, we have handles. Whoa. Can I send all this mess to some text file? Let's check it. Handles.txt. Whoa. Okay. Read the above, practice looking through the std drivers. Okay, I've done it. The edge output provided some of them will be used within a practical investigation. Okay. Oh, very nice case. One, Bob, this is not a horse. Your SOC has informed you that they have gathered memory dump from the quarantined endpoint, though you have been compromised by banking Trojan masquerading as an Adobe document. Your job is to use your knowledge of threat intelligence and reverse engineering to perform memory forensics on the infected host. This is an infected host. May want that kind of hurt my feeling. Okay, we have two cases. So we have case one. Let's start with case one. What is the build version of the host? I guess we need windows.info. Building version of the host will be this one, I guess. Wait, what? Okie doke. What is the time or the memory file acquired in a case 1? System time time stamp. Let's see which one is more suitable for our case. No, I know it is WinInfo. Which one of them? We have system time, memory, file, PE file dump. I get this one is okay. This is it. What process can be considered suspicious? In the case one process. So we need pslist can be considered. I was considering this one. Read this one. Read ls.exe. No, here. Here we what? Considered pscan process considered suspicious. Reader. Okay. SL. Reader SL. Now we have something else more appropriate. No, I get this one. Oh, this one. Okay, let's run pscan. So suspicious is I switched to this view because I couldn't see in that other view, but I was thinking about this one, or no, this is it. File output, offset, image, reader SL. Oh, I just missed the underscore. Okay, what is the parent process of the suspicious process? So parent process we've just got with PS3. Parent process of the suspicious process is Explorer. This one. What is the suspicious process? So let's see if we got it in here. 484. It's not a PID. Suspicious process. This is PID PDD 1640. What is the parent PID? Okay. This one? 1484. 1484. What is the user agent was employed by adversary user agent? Volatility dump. Oh, dump. PID. Once dump is stored. What? Okay. this dump memmap. Bit suspicious. Dump once. Okay. Let me see. Or vol.py h, and I want to grep windows. So we have memmap. Okay. Windows memmap. But wait a minute. Memmap, print memory map. But I saw there. Oh, output dir. So output dir. Oh, temp. I will take it as a temp. Dir store them. Okay, I can store it in this PIDs. We don't have this. I needed to guess that we need here. Okay, let's see. Let me see. So we have this one, and now okay. So we can see it. This is it. Pid dump extract list. So now I can dump it in here, and pid will be the 1640, and the action will be dump. Not recognized. Okay. Temp. Temp also not recognized. Why is that? Output dir. Unrecognized argument. Where do I place my arguments? Okay. So I place my arguments before the plugin. This is my problem. Before the plugin and before the F. No. Yes. So O in here. Whoa. I didn't expect this one. Okay. Now grep. Did I say grep? No. Once. Start string dump grep. The user agent. Let me see this one. Okay, let me see this one. The dump is... No, it is fine. So strings pin grep I user agent. We got him. So it is Mozilla. So it is this one. I guess. So without you the agent. Okay, no. Was Chase Bank one of the suspicious bank domains found in the case? Yes or no? Grep strings chase HTTP dump grep chase or dump chase. Okay. Chase. Indeed, it was. chaseonline.com. How do I know this is okay, Chase on logo. Online logo. Okay. Global navigation. Chase my accounts. Okay. Let me grab bank. No. No banking here, but banking? No. Okay. Security. We were talking about bank. Okay. So yes. Was suspicious process running feed in case 2? Now case 2. You have been informed that your corporation has been hit with a chain of ransomware that has been hitting corporation internationally. Your team has already retrieved the decryptor key and recovered from the attack. Still, your job is to perform post-incident analysis, identify what actors were at the play, and what occurred on your systems. You have been provided with a raw memory dump from your team to begin your analysis. So this is my second case. What suspicious process is running at PID 740 in case 2. Now we need to understand what type of operating system we are looking in here. Let me enter to the scenarios real quick. PY image info investigation 2. No image info for you. No soup for you, but if F and then image info. My bad. Nothing at all. So let's windows info. Indeed it is Windows. XP CP3. Okay, it is in Windows. So now I need malicious PS scan, malicious process. Wanna cry? Okay. I would say nothing at this point. Wanna cry decryptor. list, we understand what is suspicious process is running at. Oh, they gave us the speed 40. Wanna cry decryptor. Okay, what is the full path of the suspicious binary? The binary? What was the binary about? Which plugin can gave us the binary? DLLlist, okay. DLLlist. Can I grab this one? I wanna cry. Nope, I can't. DLL triple L list permission denied. Okay. Let's send him in there. Okay. So now we can cat the LL and grep I wanna cry. Dude. No way. It's not in here. Let me count this real quick. Okay. Here it is, wanna decryptor. So what? Wanna cry decryptor. Here it is. Wanna. It's 1N. Wanda. What's up? Okay. What is the parent process of the swarm? Okay, so parent process will be in PS3. Parent process of the WannaCry is task schedule. Okay. This is the parent process. What is the suspicious parent process connected to the crypto case? Is a suspicious parent process. They all are suspicious parent processes. Explorer, this one, CTFmon. Oh, they need a 1956. 1956? Nope. Then Explorer. 1636. 1636. Nope. Task can be found. Wait, what? What is a suspicious parent process? Oh, 1940. Same question. Dude. For our current information, what malware is present on the WannaCry? WannaCry. Hit search file indicators virus total. I don't need that. But what indicators are present in here? WannaCry. Let me search for indicators. On what indicators do we have here? So I search by the one decryptor, but one decryptor is written wanna with double N, and it is indeed WannaCry. Some versions of it. Maybe the second. WannaCry 32. So Defender, WannaCry, WannaCrypto. I don't see WannaDecryptor, but whatever. So DLL is loaded by decryptor used for socket creation. DLL list. Let me DLL list them. Or grep I socket. I think. Okay. Grep I wanna. Let's see. Command controls, no. Only no. You are Elmo, maybe. Maybe you are Elmo. Not sure, but maybe. Or this one as well. IRT util. Let's see what. Retouch DLL used by in question. Okay. Let me see. Maybe we have here DLLs, or I can take from here one of the indicators, any of them, and research it on hybrid analysis. We have here the SOC DLLs, but the only problem that they are not in any case associated with one decryptor. So maybe I will research the DLLs one by one, starting from URLmon and IERT util. So maybe quite a simple search is letting us know that it is runtime util for Internet Explorer. That essential for Windows 7 meeting. Okay. Repair, install. That's it for now. Okay, so maybe shell 32 DLL is indeed capable of opening web pages and files. This one. Shell 32 DLL. It isn't shell 32 DLL. No. RPC. Dude. I've got another candidate. WinInet DLL. Shell 32. Nothing. Okay, okay. For socket creation, This HDLL is used by in question. Okay. So maybe in the end this is it. VS232DLL. This one, VS232DLL. That's it. What mutex can be found that is known indicator of the malware in mutex handles grep. Okay. Handles. We got a bunch in here. Now by the pin. Yeah. Grep 40 60 90 40. We do have some. It's 90 40. Semaphore. Oh, hello. It's 90 40. 90 40. Gress CRS. I won't even try to read this one. Okay. User profile setup event. Indicator of malware in this. What known indicator of malware in this? I guess this one. I guess so. Looks like this one or this one. Or maybe crypt. Let's see. This isn't long enough. Indicator. Nope. Hard disk inter. Okay. X. Maybe this one. Key semaphore. Event. Mutex. Maybe I should also mutant portex. Okay. Let's say this one. Nope. So our friends in Sans are telling me that using values to find. So we are looking for mutant. Let's see the mutant one. Mutants. Mutant. Everything that has mutant in it. This is semaphore. This is mutant. Mutex AO. And we have, I think that's it. Those are the mutants in here. That's it. What plugin could be used to identify all files loaded from the malware working directory in case? What plugin can be all files loaded? Okay, let me clear my screen real quick. And find the command where I asked Volatility for help. Grep loaded kernel, loaded modules, loaded list of loaded modules, stuff, and we are searching for load kernel JSON. Nope, list loaded modules. Particular windows. Let's see. So I will grep windows and then this one. Okay. H. So we do have I guess I need to do this after C2. Okay, drivers, DLLs, and CD. Those are DLLs loaded. Not good. CMD. Okay. Files loaded from malware working directory. DLL loaded. Okay, let me grab this one real quick and see what we can get with its help. Pid all loaded. Okay, so F investigate to nope, it is not this one. F is coming beforehand. Okay, now pid 40. Can I dump this one? All the files that loaded from this is the path. This is the path. What plugin could be used? So we are trying to identify the plugin. No. Let me see all the plugins for Windows. Once again, real quick. So we have drivers, scan, dump files. No, it's not. C2. Now it is better. Info, scan, files, object present in particular Windows memory image. No. CMD. Command line arguments. Make bold. Get services. Null find. Pull scanner, nope. PS list. Memory, nope. Nope. Hybrid, PS key. User assistant. List of system calls. Scan links present particular memory. Process ranges. And we got in here CY. Could not be loaded to CY. Virt. Okay. Well, my guess is command line. Maybe it's not. No, it is efficient. It is display process environment variable. File scan file object present in particular Windows memory image. Dump files, file content from memory samples. Okay. Let's see what Dr. Google is telling us. Well, maybe it is Windows dump files. Maybe it is. Let me see. Dump files. Okay. And what do we have here? Dump files. PID object. This is physical address. Okay. Let me see. Very nice. Very nice. Volatility. Maybe these are dump files. Let me check it real quick. Nope. Not dump files. Review the help menu. Let's review the plugin, identify image profiles, hand detection capabilities, find mol find. Maybe mol find. Or Yara Scan. Mol find. Yep. Not that easy. Hooks. Mod scan. Driver. Code pics. API hooks. Handles. Maybe handles. Mode dump. Handles. Handles. Wait, what? So let me see files. Maybe these will be. So we have Windows file scan dump. Windows file scan. Okay, file scan. Plugin could be used to identify all the files loaded from the directory. Okay, now I want to see this one. No arguments. Oh, file scan. File scan. Wait, what? File scan. Oh. Usage. Windows file scan. Windows file scan. Maybe help? Okay. I will guess that we do have some kind of no, we don't. No, we don't. Windows file scan. Windows files scan. Maybe like this. Yeah. Nope. Scan file object present input. Okay. Okay. Maybe then I want to grep I wanna. Okay. Here we go. So now that I'm filtering it by wanna, we can see all the files that were loaded from this folder. Okay. Now we have the project, we have poster, and we have finished it. Well done. That's it. Bye bye.